Today we are going to talk about basic differentiation rules. So let's start with the constant rule. That's a constant function, so f of x equals some number. And the rule is that if that's the case, then the derivative of that is going to be 0. So how can we prove that? Well, we're going to set up the limit as as delta x approaches some, delta x is going to approach c. So one of the formulas we use is f of x plus delta x minus f of x divided by delta x, right? But the thing here is that even though there's x and delta x, the expression is still c. F of x is still c. So the limit as delta x approaches 0, you're going to end up getting c minus c divided by delta x. Now remember that delta x is technically never 0. It approaches, it becomes infinitely close to 0, but it's never going to be 0. The numerator is constant minus itself is going to be 0, so the whole thing is 0. The next one is if the function is a linear function, so f of x equals mx plus b, then the derivative, that's another way to write derivative of f of x, is going to equal m, which is basically the slope. How can we prove that? Well, we're going to set up the same thing. Limit as delta x approaches 0 of f of x plus delta, so f of x plus delta x minus f of x divided by delta x. So here we do have x, so it's going to be the limit as delta x approaches 0. So f of x plus delta x, you substitute x plus delta x into m, into x right next to m. So m times x plus delta x plus b minus the formula itself, mx plus b divided by delta x. So what are we getting from here? We're going to get, if we distribute all that, whatever we have there in the numerator, it's going to give us mx plus m times delta x plus b minus mx minus b all over delta x. So let's take a look. So we have mx minus mx, those two cancel. You have b minus b cancel. All you have now in the numerator is m delta x divided by delta x. So limit as delta x approaches 0 is going to be m times delta x divided by delta x. Delta x and delta x are going to cancel each other, and the answer is m, which should be pretty logical, because if we're talking about the derivative being the slope of the tangent line, then it is going to be the slope itself, because the line has the same slope. Alright, a power rule. I'm not going to do a complete thing, but what I want you to understand, when you write expansion for x to the power n, and we need to do x plus delta x to the power n, the way it's going to work, you're always going to get, if you remember the binomial theorem or even the Pascal's triangle, it's always going to be x to the power n first, plus n times x to the power n minus 1 times delta x, plus there's going to be some number, if we call that number, let's call it p1, so p1 times, we're going to get x to the power n minus 2 times delta x squared, plus etc. You will see in a moment why we need that. So when we write this expansion, and for the sake of saving space, I'm going to write what I'm trying to set up here. So this is x plus delta x to the nth power minus x to the nth power divided by delta x. So we're gonna get what x to the n plus n times x to the n minus 1 times delta x plus some number times x to the power n minus 2 times delta x squared plus etc. And then all that is for the first part minus x to the power n. There is a formal proof of that, but that's not the purpose of what I'm trying to do here. Here's what's going to happen. When you expand this, first of all, x to the power n is going to cancel. And then I want you to notice the following. From what's left, the first term is the only one that's going to contain 1 delta x. All the other terms will contain delta x to a higher power. So when I factor out delta, but each one of them is going to contain delta x. So if I factor it out, I will be factor it out, and when I do, each one of them is going to start canceling. And as a result of this, once I get to this final expression, this here, n times x to the power n minus 1, will be the only one that does not have delta x. And all the terms that are going to follow will have delta x to some power. So all those will zero out, and the only thing that's going to be left is n times x to the power n minus 1. Okay? So don't worry about too much if you don't really understand it. It shouldn't stop you from being able to do it. Okay, and finally, constant multiple rule. That's when you have some function g of x, which is a constant times another function, and we claim that the derivative of that function is going to be that constant times the derivative of the other function. Please don't confuse that with the constant rule, where the function is just a constant function. So if we set this up, it's the limit as delta x approaches 0. We're going to have c times f of x plus delta x minus c times f of x divided by delta x. So according to the properties of limits, I can factor out this c from this expression, and then because it's a constant, the constant can be taken outside of the limit. So it's going to be c times the limit as delta x approaches 0 of f of x plus delta x minus f of x. We don't really care what the f of x is. It is some function. The limit part of this here is nothing else but f prime of x. Right? So the whole thing is c times f prime of x. Okay. Alright. So now it's time to try some problems based on this. Alright. And it is very easy, very basic. Let's start with the example 1. So find f prime of x if f of x is equal to -5. Well, it's a constant, right? So f prime of x is going to equal 0. Yes, that's simple. It doesn't matter what that number is. And think about this. If this is what we call this is a constant function, that's a horizontal line. And what is the slope of a horizontal line? You guessed it right. It is 0. What is the slope of g of x when g of x is... I'm sorry, what's the derivative of g of x when g of x is 3x plus 4? No. G prime of x is going to equal 3. Yeah, we already established. And again, that's consistent with the slope of the line itself. Alright, so now we have h of x, that's x squared. We want to find h prime. So h prime of x will be, if we're going by the rule, we take the exponent, put it in the front as a constant, and then times x to the power of 2 minus 1. We drop the power by 1, so it's 2x. Let's try to do the same thing. So we're trying to find d over dx if f of x is this. So we're differentiating f prime, right? So d over dx of x to the fourth is going to be, so it is just like this problem. We take 4, put it in front, times x, and the power here is going to be reduced by 1, always by 1. So it's going to be 4x cubed. Alright, something that's not as obvious. How do we differentiate square root of y with respect to y? Well, when you try to do that, what you should do, this is the easiest way to view that, is we're going to rewrite square root of y using rational exponents. So it's y to the power 1/2, right? And then this rule will apply. It doesn't matter what these exponents are. They could be whole numbers, fractions, decimals, doesn't change anything. So it's going to be 1/2 goes to the front times y to the power 1/2 minus 1. Well, we'd like to simplify it. So it's 1/2 times y to the power negative 1/2. And that's a possible way to write that, but if we don't like leaving negative exponents in algebra, that's going to be actually 1 over 2 square root of y. Okay, and lastly, this is the one that you have times 5 times t cubed. So when we differentiate that, we should pull 5 outside, makes things easier, times d over dt of t cubed. So 5 times the derivative of t cubed is going to be 3 times t squared. I hope you understand that by now. And that whole thing is going to be 15t squared. Alright. A few more. So now it's the actual application. So find the slope of the line tangent to the graph. When you hear the word slope of the tangent line, you should immediately think the derivative. So our function here is given g of 1 is x to the 5th. So what we need to do is g prime of x is going to be 5x to the power 1 less than 5. So 5x to the 4th, right? And to find the slope is going to be g prime of 1. So it's going to be 5 times 1 to the 4th, which is 5. And in example 8, we want to write the equation of the tangent line. So now we need to do a little bit more work. Remember, we need the point and the slope. So first, I would suggest, since we're given the x value, let's find the y value. So h of 2 is going to be 4 divided by 2 squared, which is going to be 1. That means our point is 2 comma 1. And now we need to find the derivative. So h prime of x, I'm going to do the following. I'm going to write that as 4 times x to the power negative 2. Okay? And then I can follow the rules. So a constant multiple 4 can stay outside. You don't really do anything with that. Here we're differentiating x to the negative second power. I forgot prime. So it's going to be times x to the negative second power. We differentiate that. So 4 times the power goes to the front as a multiple, and then we're going to have x to the power of negative 2 minus 1. So it's going to be negative 8 times x to the negative third power, which you can write as negative 8 over x cubed. Correct? And now we need the slope, so we need to substitute that 2 into the derivative. So it's going to be negative 8 over 2 cubed, which is going to be negative 1. So our slope is negative 1, right? And the tangent line is going to be, so we use point slope form, usually. So it's going to be y minus 1 equals -1 times x minus 2, right? Here's our slope, -1 goes there, and these are our values of x and y. So they go there, and you're done. Okay? So that's the basic rules. Hope this helps.